This is going to be homework 16. So we're going to start with problem 1. The motion of a 2.5 kilogram rod AB is guided by a small wheels which roll freely. If the force P of magnitude 8 newtons is applied at B, determine the acceleration of the rod and the reactions of A and B. So this is our rod. It's a lot smoother than it is here. It's actually more of it's a quarter circle, and this is the center point, the radius. So what we do is we're going to have to set a free body diagram. Free body diagram is going to show all the forces in the x and y direction. We're going to have a normal force at A, normal force at B. P is going to be the force that's applied. We're going to have the weight at the center of mass, which is it's going to equal our kinetic diagram, which is going to be the center of mass at times mass having an acceleration. So for a quarter circle, these are the locations of the center of mass in the x direction and the y direction. So what we do is we can actually set the acceleration of the rod as the sum of the forces in the x direction. So we're going to set our P force equal to our mass times acceleration. And what we can do is we know our P is 8 newtons. We know our mass. We can just divide force by mass and get our acceleration. So 8 divided by 2.5 gives us 3.2 meters per second squared. Now, next we're going to do the reactions. The reactions are going to be the sum of the moments at B. So we're going to have a normal force here going in the clockwise direction, and it's going to be 0.3 meters away from the point of rotation from point B. Then we're going to have our weight. The weight is going to be our mass times gravity, and that's going to be a set distance here. We're going to subtract our x term here, 2 pi r, and so that will give us this location. Then on the other side, we're going to have that equal to our P force that we were giving it here, and that is also going to be applied at the center point there, so it's going to have our x term for its location for the center of mass. Multiplying that through, we're going to have 8 newtons times this. Here we're going to have 2.67 once we put that mass times gravity times this. And then we're going to solve for NA. Divide this term by 0.03, and then the normal force at A gives us 3.81. So now what we can do is we can do some of the forces in the y direction. We're going to have normal force at A, normal force at B, and then the weight. So we do that, normal force at A, normal force at B, subtract in the positive direction. Downward is going to be the weight, and then we can solve for B. So that's the first section for the first problem, and we'll be doing the second one next. Okay, this is problem 2.